Have you ever really stopped to think about what happens when a computer sees a picture? I mean, what's actually going on under the hood? Well, today we're going to do just that. We're going to follow one single image on its wild journey through a convolutional neural network, or as you probably know it, a ConvNet. Let's trace its path, step by step.
It all boils down to this one question, right? For us, it's instant. We see a cat, we know it's a cat. But a computer doesn't see, it just sees data. A ConvNet is a machine built to solve this exact problem, to hunt for patterns in pixels that scream cat or car or, anything else. And this is our roadmap for the journey. Don't get too bogged down by all the numbers just yet. The main idea is simple. Our starting image on the left gets passed through a whole series of layers. Each one of those blocks is a transformation, changing the data and getting us one step closer to an answer.
Okay, so every journey has to start somewhere. For our ConvNet, the starting point is just a single digital image. This is the raw material we're about to feed into the machine. Now here's where it gets interesting. To the computer, this isn't a picture, it's a block of numbers. Specifically, a block that's 39 pixels tall, 39 pixels wide, and 3 layers deep. And that 3, well, that's for the red, green, and blue color channels that mix together to make all the colors you see. All right, our image is officially at the front door of the network. Now we're heading inside. This is where the real magic happens, where those raw pixels get turned into something meaningful. Let's see how the very first layer kicks things off. First up, layer 1. The best way to think about this layer is that it has 10 tiny digital magnifying glasses. These are our filters, and each one is just 3 by 3 pixels. They slide across our image, 1 pixel at a time. That's what a stride of 1 means. And each one is on the lookout for a super basic feature, like a tiny edge or a simple curve. So how does that actually change the size of our data? Well, there's a pretty straightforward formula for it. You take the input width, which is 39, subtract the filter size, 3, divide by the stride, 1, and then just add 1 back. The result? Our 39 by 39 image shrinks down just a tiny bit to 37 by 37. And boom, this is our first major transformation. The data is now a 37 by 37 block. But look at that depth. Because we use 10 different filters, each one hunting for a different pattern, our data is now 10 channels deep. We've basically traded a little bit of height and width for a whole lot more depth. Let's keep it moving. On to layer 2. The setup here is a little different. We're using 20 filters this time. They're a bit bigger at 5 by 5, but the most important change here is the stride. It's now 2. And what does a stride of 2 do? It means our filters are taking bigger jumps. They're skipping a pixel each time. This has a huge effect. The network starts summarizing what it's seeing way more aggressively, and that causes the height and width to shrink down much, much faster, all the way down to 17 by 17. So after that second stop, here's where we stand. Our data is a 17 by 17 block. But since we used 20 filters this time, the depth has doubled to 20. See the pattern? It's getting smaller spatially, but much, much deeper with information. All right, let's hit the last convolutional layer in our little tour. The pattern keeps going. We're still using 5 by 5 filters with a stride of 2, but now we've doubled the filters again, all the way up to 40. The network is now looking for even more complex combinations of the features it found earlier. And here we are. After that final step, our original 39 by 39 image has been crunched down into this incredibly dense block of data, a 7 by 7 by 40 feature map. All of the most important patterns from the original image are now encoded right here in this compact little volume. Okay, let's just hit pause for a second and take a step back. We've zipped through 3 layers, and a really, really important pattern has emerged. Have you spotted it yet? Let's lay out the numbers and take a look. This right here, this is the aha moment. This is the core design philosophy of so many ConvNets. As you go deeper into the network, the spatial dimensions, the height and width, get smaller and smaller, going from 39 all the way down to 7. But at the exact same time, the channel depth gets bigger and bigger, exploding from 3 to 40. We're squeezing the where information into a much richer what representation. So we have this rich 7 by 7 by 40 block of features. That's great, but how in the world does that become a simple answer like, yep, that's a cat? The network still needs to make a final call. To get there, we do something that's actually pretty simple. We take that entire 3D block of data and we just flatten it. We unroll it into one single long line of numbers. That's it.
And how many numbers are in that line? Well, you just multiply it out. 7 times 7 times 40, which gives us 1,960. That's right. All that feature extraction has boiled the image down to a list of almost 2,000 numbers that represents everything the network thinks is important. And finally, this long vector of 1,960 numbers gets passed to the last part of the network, the classifier. You can think of this as the final judge. It looks at the entire pattern of numbers and calculates the odds, making the final prediction. Okay, based on all this evidence, there's a 95% chance this is a cat. Now, what we've seen today is the journey through the absolute workhorse of these networks, the convolutional layer. But it's good to know that most real-world networks use a few other tools in their toolkit, like pooling layers to shrink things down even more efficiently, and fully connected layers at the very end to help make that final decision. So we followed one very specific path that an image can take, but this is just one possible architecture. And that kind of leads to a final thought, doesn't it? If changing the filter size or the stride creates a whole new path, what other, crazier journeys can we send an image on to unlock even more of its secrets?